Okay, so we have been looking at the idea that an op-amp not only amplifies the difference of the two signals, but also amplifies the common mode signal that is applied to it. Okay, is there, however, any relationship between the difference, how much between the values of AD and ACM? Okay, so for a good op amp, so for a op amp that is approaching the ideal op amp, what would you want? You would want ACM to be as low as possible and the differential gain, that is AD, to be as high as possible, right? So the measure that often op amp manufacturers and people use to tell you how close the op amp is to the ideal op amp is called CMRR. Okay, CMRR stands for common mode, and you already know what we mean by common mode. Common mode is the average signal that is applied, the common signal that is applied to the inputs of the op amp, right? So CMRR stands for common mode rejection ratio. Okay, so it is how much does the particular op amp reject the common mode. Okay, and how is CMRR calculated? CMRR is basically calculated as AD over ACM. Okay, so the higher the value of the CMRR is, the better the op amp is, the closer the op amp is to an ideal op amp. And usually this ratio that we have of CMRR is not measured in a linear scale, but it is measured in a log scale. So you write CMRR, usually you measure it in dB, okay, in decibels, and that is given by 20 log to the base 10 AD over ACM. Now, of course, in this case, we are assuming that AD and ACM are positive, or if they are not, then we just take the magnitude of that to calculate the common mode rejection ratio. And you can look up a few data sheets of a few op amps or the op amp that you're using and look up what the CMRR is. And what you would find is for many op amps, the CMRR is probably 60 dB and sometimes even 90 dB, maybe approaching to 100 dB. So let's say if CMRR is 100 dB, what does that mean, right? So if CMRR was 100 dB, and let me write this in a different color. So what we are saying is 100 equal to 20 log 10 AD over ACM. Okay. Okay, I have what I've written is occluded by my picture. So, okay, that seems to be all right. And this implies that log 10 AD over ACM equal to 5. This means that AD over ACM equal to 10 to the power 5. And that's quite a lot, right? So the common mode gain is 10 to the power 5 times less than the differential gain. So basically, we are almost there, very close to the ideal op amp, right? So, so, uh, so hopefully that makes sense.